Welcome to Mathematics Lecture Series, Laplace Transform. Laplace Transform Lecture number 1. Now we find first Laplace transform of some elementary function. Laplace of 1, Laplace of 1. So by using definition of the Laplace transform 0 to infinity e power minus st. This is one reading. Taking the integration of this e power might become e power minus st upon minus s. Now apply upper limit, so it becomes e power minus lower limit e power 0. So minus 1 over s e power minus infinity means 1 over e power infinity, 1 over e power infinity, 1 over infinity which becomes 0. 0 minus 1, so it is 1 over s must be greater than 0. Now Laplace of t. Similarly, by definition of the Laplace from 0 to infinity e power minus st t dt. This integral solved by integration by pos. This is an improper integral, so we apply limit p to infinity. Here t is same, taking integration of this e power minus st according to t. So it becomes e power minus st means 1 over e power st, and integration of st is minus s, which is we have at the denominator upper limit p and lower limit 0 minus integration 0 to infinity. This is minus by the formula of integration by parts. So here derivative of t is 1 and the integration we write e power minus st or minus s dt. So if we apply the upper limit, and it will goes to infinity, and by the lower limit, so this whole term goes to 0, and we have minus into minus plus, just we have 1 over 0 to infinity 1 e power minus st dt. You can see that this is a Laplace of 1. So by definition we write in the place of this 0 to infinity 1 e power minus st dt Laplace of 1. And what is Laplace of 1? 1 over s. So 1 over s square is the Laplace of t. Here you can note that limit p to infinity 1 over e power sp is 0, because 1 over we apply the limit 1 over e power infinity 1 over infinity, it is 0. Now similarly you can easily find Laplace of t power n. So by definition of Laplace transform integral 0 to infinity t power n e power minus st dt. Use integration by parts formula. So u is t power n means we deal the derivative of t power n. V e power minus st means we deal the integration of this term. So Laplace of t power n, limit p to infinity t power n is same, e power minus st over minus integration of this e power minus st, minus by the formula of integration by part 0 to infinity derivative of t power n, which is n t n minus 1, e power minus st minus s, the integration of this term e power minus st dt. Now similarly this term goes to 0, so we have just n over s 0 to infinity t power n minus 1 e power minus st dt. What about this? This is Laplace of t power n minus 1. By the definition of Laplace transform, we can say that this is the Laplace of t power n minus 1. So now on second slide we can see that Laplace of t power 1 t power n n over s Laplace t n minus 1. So here Laplace of t power n n over s, and by the formula we adopt this recurrence relation. We have n minus 1 over s, n minus 2 over s, 3 by s, 2 by s, 1 by s, and Laplace t power 0. So Laplace of t power 0 means Laplace of 1. This will, if we apply the definition of factorial, it becomes n factorial s power n. N factorial s power n. So Laplace of 1 is 1 over s. So n factorial s n plus 1. So Laplace of t power n is equal to n factorial s power n plus 1. Here s must be greater than 0. If we apply the definition of gamma function, so gamma n plus 1 is 0 to infinity e power minus u power n du. It is equal to n factorial. So we can replace this n factorial by gamma n plus 1 s n plus 1. Also Laplace of t power n is equal to gamma n plus 1 s power n plus 1.